So now we're going to learn about combinations and permutations. And there is a difference between the two, and that's really the thing I want you to make sure you understand really well by the end of the notes in the practice. A permutation is something where your order is important. So I know it's called a combination lock, but if you have a lock, it's really important that you know the numbers in the lock. The order you enter those numbers in means something. If you're in a race, first, second, third, again, that order means something. If you arrange kids in a line, who's first, second, third, when you're in elementary school, that order meant something. You wanted to be that line leader of the caboose. Now, we have a formula for permutations. It's N permute R, and it is subscript here. My examples above, I'll get to them later. I couldn't do the subscripts, but it is subscript. N is how many objects you have that you are arranging or listing. R is how many that you're selecting. So we're going to have our factorials again. It's going to be N factorial over the difference of N minus R factorial. Combinations, the order does not matter. If you're making a smoothie, it doesn't matter if you put in the strawberries or the raspberries first. Putting veggies in a salad, doesn't matter how you put those veggies in. Picking groups, if you have 20 kids, you're just splitting even groups. I want 10 here, 10 here. The order you pick the kids to be on the group does not matter. So that's a combination. The order does not matter to the ending. A lot of people like to think, hey, permutations, that's a little bit more trickier of a word. So permutation, the order does matter. It's a little trickier to figure out. Where combination, hey, it doesn't matter. I'm putting pepperoni and hamburger on my pizza. It doesn't matter which one I put. So for combination, since it doesn't matter, it's a little bit easier to figure out. Our formula for combination is N, again, the number you have to choose from, and then combinations, and then R, how many you're actually selecting. So that is N factorial over R factorial, and then N minus R factorial. Yes, it's a little bit more complicated, but I'll share an easier way to do that afterwards. So we want to identify, hey, is it permutation or combination? Then we can go ahead and figure that out. Let's try this one out together. The manager of a coffee shop needs to hire 2 employees, one to work at the counter and one to work at the drive-thru. So we're picking 2 people for 2 different roles. Laura, Mike, Nora, and Ollie all applied for a job. How many possible ways are for the manager to place the applicants? So this actually, because there's one for the drive-thru, one for the counter, it is a permutation. How many people do I have to choose from? I have 4 people to choose from. And how many am I going to pick? 2 people I'm going to pick. So it's 4 permute 2. If you wanted to use a calculator, and I have this at the top of the notes, you would type in 4, then you'd hit that PRB button, arrow over to NPR, select that one, then hit 2, and then equals will give you the answer. I want to show you, because the numbers are small, how to set it up with a formula without using a calculator. So we're going to have 4 factorial over 4 minus 2 factorial. Okay. And what is 4 minus 2 factorial? That's 2 factorial. So I have 4 factorial over 2 factorial. I'm just going to dash this out a little bit if I can. So when I am actually solving it, I'm going to start showing what factorial means. 4 times 3 times 2. I'm not going to keep going. I'm just going to leave it at 2 factorial, because what do I have in the denominator? I have 2 factorial. So my 2 factorials, I don't need to go all the way down to 1. I can cancel those out. And what's 4 times 3? We have 12 different possible ways for 2 people out of the 4 to be hired for 2 different roles. I want to just show you another way of doing this, because again, if you don't want to memorize these formulas, think about how we would do this. So she has to hire 2. This is my counter. I'll put a C here, and this is my drive-through. Put DT. How many choices does she have to pick somebody to work at that counter? Well, there's 4 people, so she has 4 choices to put somebody at the counter. Now she hired one person for the counter. How many people does she have to choose from for the drive-through? Well, there's 3 applicants left. So what's 4 times 3? 12. Okay, just another way of doing that permutation problem. All right, let's look at problem 2. How many different ways can 2 parents be chosen from a group of 12 willing parents to be chaperones on an upcoming field trip? Well, does it matter who I pick first or second? I'm just picking 2. It doesn't matter how I pick those parents. So this would be a combination. So I have 12 parents, and I'm going to choose 2. So let's put that into that formula. It's going to be 12 factorial over 2 factorial, and then 12 minus 2 factorial. And again, what is 12 minus 2? That's 10 factorial. So I want to show you a trick that hopefully you use because it will make your life a little bit easier. Let me just cross that off. Always look at what the bigger factorial is in the denominator, and that would be 10 here. So when I'm writing out my 12 factorial, I am going to stop at 10 factorial. I am not going to keep going because I have a 10 factorial here. I do want to make sure I write my 2 factorial out though, and it might be something bigger than 2, but make sure you write that out. So now I will simplify the 10 factorial over 10 factorial, and instead of multiplying 12 times 11, why don't I simplify that as well? 12 divided by 2 is 6. So I have 6 times 11, which is 66 different ways to hire those, or not hire, sorry, to pick 2 parents out of 12. If I wanted to do something with the lines instead, I'm picking 2 parents, and it doesn't matter the order. So I have 12 choices for the first parent and 11 choices for the second parent. And again, it doesn't matter the order. So once I multiply those, I would have divided by 2 because the order is not important. And again, I get my 66 different ways to pick those 2 for the field trip. All right, so problem 3. Diane has a bag full of coins. There's 10 pennies, 6 nickels, 4 dimes, 2 quarters. How many different ways can she pull 4 coins out of the bag? Doesn't tell us, it matters the order, so this is a combination. So how many coins does she have? If we count that, we get 22 coins. And how many is Diane going to pick from those 22? She's going to pull out 4. Again, order doesn't matter, so that's a combination. So I know the formula is on the front page, but I'll just remind you, it's going to be your n factorial in the numerator. And then over r factorial. How many is she picking? And then it's going to be n minus r factorial. Again, let's simplify. 22 minus 4 is 18. All right, if you have a calculator, this one's a little bit easier to put in there. If not, you're going to do 22 times 21 times 20 times 19, and you're stopping at 18 factorial because that is the largest in our denominator. Make that exclamation point. And then 4 factorial, 4, 3, 2, 1, and then 18 factorial. So we'll simplify our 18s. I'm going to say, hey, 4 goes into 25 times. 3 goes into 21, 7 times. 2 goes into 22, 11 times. So then I just have to multiply 11 times 7 times 5 times 19. And we will get 7,315 ways to pull 4 coins out of a bag of 22 coins. Again, calculator, you would do 22, hit that probability button, arrow to combinations, hit 4, and then you'd get your answer. All right, problem 4. Shannon has now a 5-digit passcode to get to her email. It's made up of even digits, 2, 4, 6, 8, and 0. Each digit can only be used once. How many different passcodes can Shannon have? Let's try this with the lines. 5 digits. So she has 5 choices for the first, 4 choices, 3 choices, 2 choices, and 1. So we can multiply that. That's really 5 factorial. And 5 factorial will give us 120 choices. if I use this, again, this is a permutation because the order matters. That would be 5 permute 5. So I'll have 5 factorial in the numerator, and then it's going to be n minus r in the denominator. That's 5 minus 5 factorial, which is actually 0 factorial. And I did not tell you this in the previous video, but 0 factorial is actually equal to 1. So we get 5 factorial, which we just did out over here, 5, 4, 3, 2, 1, all multiplied together, gives us that 120 again. So now the second part of this, problem B, is saying, well, Shannon has to have 8 as her first number. That's her favorite number. So 8's her first number. So how many choices does she have for the next number? Well, if 8's already taken, there's only 4 numbers left. And I'm going to cross this 8 off because 8's in that spot. So I'm just going to put 1 there. She only has 1 choice for that. So she has 4 choices for the second number, and then 3 choices, and then 2 choices, and then there's only 1 number left. So if I were to multiply those, she has 24 different passcodes if we know that 8 is first there. For these last two, I'm going to read them. I want you to write down P or C, and then why don't you pause it and see if you can come up with the right answer, and then we can check back. So customers at Tony's Pizzeria can choose 4 out of 12 toppings for each pizza at no extra charge. How many different combinations of pizza toppings can be chosen? So write down P or C. And then 6, there are 15 racers that have qualified for the final event. And how many ways can the racers finish in first, second, and third place? So again, put P or C. All right, so for 5, this should have been a combination. In 6, since they're placing, it's going to be a permutation. So pause it, try those on your own, and then unpause it to see the answers. So for 5, we said it was combination, so 12, choose 4. So I have 12 factorial over 4 factorial, and then I subtract to get 8 factorial. Again, only go up to 8 factorial, simplify. I simplified, I don't know if you can see this, 4 times 3 is the same as 12, so I took those off. So we get 495. And then for 6, it's 15. You're picking 3 there. So 15 times 14 times 13. Again, the 12 factorials canceled out. We have 2,730. And this one here, you could have, again, used the lines. Permutations is great for lines. We have 15 choices for first, 14 choices for second place, and 13 choices for third, giving us that 2,730. So again, really make sure you try to understand order is important for permutations. Combination, the order does not matter. And then you can use your formulas. Simplify, you can use the calculator too. This is fun to do every once in a while. So good luck with the practice.